Welcome to Academic Digest class. So today I want to teach you relative velocity. Let's pen. Velocity. So we say that relative velocity is the motion of a body as observed. The motion of a body as observed by another body. So think of it. If a car is moving and someone is in that car, and maybe someone is standing on the ground looking at that car. So as this car moves past this guy, he will notice some type of motion. So the motion you observe if this guy is sitting down is the car's relative velocity. But if as the car is moving, this person is also moving. So the motion you observe is the motion of this person plus the motion of the car. So what it simply means is that in one dimension, relative velocity is simply motion of this person. Let's say there is motion of this car. Let's say this person is standing on the floor, and this person is inside car. So in one dimension, relative velocity is simply for this person is relative velocity. Let's say this is A, B. So car and the person A. So his relative velocity as observed by this person will simply be car plus person A, then minus him. He's just standing, minus his own relative velocity. So notice something. This is a case where this person is not moving and this person is moving. And notice, if that is the case, if that is true, it simply means that we can easily take it that it's more like saying that this person is going this way and this person is going this way. So if that is true, notice that if this is x-axis, this is positive. And if this is x-axis, this side is negative. So that means that if this is going this way, that means that this person, the relative velocity of this person will have negative as well. So now notice something. Car plus this person, that is the velocity of the car and the velocity of this person, minus will become plus relative velocity of person B. So whenever is moving in opposite direction, so assuming if this person is in a car and moving as well, and moving in opposite direction, it will simply be that relative velocity is equals to, in this case for opposite direction, relative velocity of the first body plus relative velocity of the second body. This is the first, the whole thing here is the first body, the whole thing here is the second body. Now, a situation where it's moving in the same direction, so the key thing there is that relative velocity will always have minus something. So if it's in opposite direction, it will not be minus. So when it's in the same direction, so for one dimension, when it's same direction, so assuming a person is moving in this way, let's say a bus is moving in this way, and another bus is moving in this way. So the relative velocity as observed by each of them, let's say here, the person here, let's say this person is velocity 1, velocity 1, velocity 2. So as observed by this person, the first person will see relative velocity as the other person's relative velocity. So let's say V2 minus V1, or you say velocity. Let's use velocity. So velocity 2 minus velocity 1. And this person we see his own relative velocity as, so the relative velocity of the first body, second body. So this person, this person, this person is seeing the velocity of this person. That is here. He's seeing the movement of that person. So minus his own. Why this person will see the velocity of this person? So relative velocity has to do with velocity that you can relate in terms of another, like you are looking at another motion and relating it to your own motion or where you are. So you will see R1 minus, that's the first velocity, which is V1 minus V2. So you see that is minus because they are both moving in the same direction. So it's like plus axis. And assuming it's in the opposite axis, it will still be the same thing. So like what I'm trying to say is if it's the same direction, it will have minus because naturally relative velocity is supposed to be velocity of uh, uh, body observed. Velocity of body observed minus, so it's supposed to be velocity of body observed minus velocity of observing body. So if the observing body now is moving in opposite direction, it will now be v observed minus v observing, which will change to plus. So this is opposite direction, this is same dimension. So if I know that, let's look at when it's in two dimension. In two dimension now, a situation where, so relative velocity in two dimension. So in two dimension now can be a case whereby you hear like a river. Let's say they tell you a river is flowing due east. See river flowing due east at a velocity. So it's flowing 30 kilometer per hour. Or sorry, let's say meter, 30 meter per second. Now, a man wishes to row his boat. So you see, first, it's more like a situation where you have this way or this way. However it is, but it's in two dimensions. It's like horizontal and vertical at the same time. So a man wishes to row his boat north. If this man wishes to row his boat north, that is to go north. Notice that if he sets out north across the river, what you should be thinking of, unlike my first class, what you should be thinking of in this case is if this man wishes to cross, because the river is moving, anything river or helicopter, as air is blowing it, wind will be blowing, trying to push it in the other direction. So if it sets out to move straight, if it's trying to move straight, that means that the water will be, since the water is going east, the water will be moving it like this, moving it to this axis. So for that reason, there are two cases here. So cases of when he tried to move straight, he will be tending towards the east. And that means that the current, this movement is current, and opposite of it is upstream. So his current will be towards the east, while his upstream, that is his upstream, which is what the direction of the boat will carry, will be towards the west. What this thing means is that if you are applying upstream, as you have this thing here, you will now see that since the river is flowing this way, and this is 30 meter per second, that for him now, the direction of his boat, he will have to set out his boat in such a way that he's going towards the west, like north of the west, sorry. He's going towards north of the west, so that as the thing is, the current is trying to push him, is trying to push him, at the end of the day, he can now get to the north. You see it? At the end of the day, he can now get to the north. So that is why You see most diagrams like this, they tell you this is the triangle. That this is the triangle. They now tell you that the angle is made like this. The angle is made because they are trying to tell you that at the end of the day, since he sets out, north can be here as well, north can be here. Since he sets out, that by the time he gets there, he has gotten to the north, like it has pushed him. Then the angle is made. This is where the angle is made. His boots and getting to the north. But a more practical aspect of this, because in reality, somebody going to the north can take corners, but a more practical aspect of this should be you knowing that if he's heading to the north, because this is how you want to think first. If he's heading to the north, the movement currents will try to push him, and at the end of the day, he will still get to the north. But look at how the triangle will now look. This is it. And notice that whatever line you have here is the same line you have here, equilibrium. But notice that it's now in this way. So it's more like saying the boat set out from here, but it now moved slanted to get to the north, theta. But why they normally use this one, why they normally use this particular approach, is so that you will be able to say that at the end of the day, his direction is north degree of west. If it's not, he's going to. But you notice that if you do this one now, your mind will point you. Your mind, because see what I mean by not degree of west. Notice something here. Notice something here. If you notice, this is north. And the angle that will be made here, the angle made here, is angle of theta. And the same angle, alternate angles. So if this is north now, this side is west. You see it, which is the same thing with when you have it here. When you have it here. So he's trying to tell you that why they normally draw it this way is for you to know that from where he sets his boat out, not really where he gets to, that from where he sets his boat out, if you check it, the direction he will set his boat. If that question is asked, direction which he must head his boat. So the direction which he must head his boat from here will be towards the west, north of west. That's why they normally set it like this, because if you now as a student draw it from this angle, but this is the more practical approach, so you must understand it too for you to be able to answer that question. So if you set it like this now, you see that by the time you get here, this is north, and notice what is happening here. What is happening here in your eye? If you are judging this, you'll be judging this, but forgetting that what this thing means is that he has already gotten to the north in this case. And the angle that you have here, this angle that you have here, is from when he started. And that when you started, the angle was on this place. And this is east, north of, this is north. This particular thing is north and is even east of north. So you can see that by this your approach, what you are judging actually in this approach, what you are judging in this approach is the river or the water movement. That's what you are judging, not really his boat. Because remember, you in your eye, when you wanted to use this movement, you set out the boat to be going north direct, and that boat going north direct and now slants to this point. Now what made it slant is actually the movement of the river, making it bend like this. But if you really want to judge this by boat itself, it will be that the boat will want to head this way, and at the end of the day, the river will now make it to come to the north, and that north it will come to, even if you put it here, it's still the same thing parallel. So that is why you need to understand these two things. If you understand these two things, you now need to always make sure that as you are doing this, you are solving this, you apply this approach, so that you say that whatever they are asking you, let's say another question, they tell you a man sets out to swim across a river. If he's swimming, he can control what he's doing. If he's swimming, he will control what he's doing, because as he's swimming, he's using his strength and he won't go much. Then they tell you he maintains a steady speed. Steady speed means he will move this way. then this way. So in that case, what you will have is simply his speed this way, and then maybe the river movement this way, the current this way, river current this way. In this case, it's like this. But a question where you have boat or something, once you see that boat, have it in mind that something like this will happen. You must consider the current movement. How is the current moving? And which direction will he want to put his boat to get to where he's going? You grab now. So once you understand this concept, it becomes easy for you to answer any boat or river question. So in this case now, what it will mean is that let's look at this now. Well, I'm using this question. A student solved this, but I've not checked the answer, but I'm just using the question. So if a man is wide, due east, says a river 15-meter wide, due east, and at a velocity 30 meter per second, a man wishes to row his boat due north across the river. If he can row the boat in still water at 15 meters, calculate. All the English they spoke here is okay, but for you to calculate the boat, how it will head, is using this approach. So this is going to be that a boat in still water, the velocity of the boat 15 meters per second. So what it means is that the vector that you are going to resolve, will always be resolved by looking at how the current is moving and how the boat will move. So how current river will move and how the boats will move. So I'm not going to solve this question here because I'm solving it in my next class. So you just look at that video. But what I'm doing here is to teach you the concept. Okay, but let's just solve. So this is going to be 15 meters per second. So at the end of the day, you see that you don't know this side. But using if you want to use resolution, you can say resolving this now. Let's say this is not resolving this now, this particular thing that you've made here to the north or to the east. But simply you can actually say to find theta here, theta will simply be notice is looking at this opposite. So let's check sine theta first. Sine theta will simply be 30 opposite over hypotenuse, and theta will simply be sine inverse of 3 over 5 because the zeros will cancel. So sine inverse of 3 over 5, theta will be equals to 36 thereabouts, 36.87, which is approximately 37 degrees. And to find this axis, I can also do yes. Now that I have theta, I can do cos theta equals to adjacent over hypotenuse, which is equals to, that axis is the y-axis. So y over 50, and cos theta is the same thing as saying cos 37 degrees equals to y over 50. So 50 cos 37 is equals to the y-axis. So here's my calculator. So 50 cos 37, so 39.9, y is equals to 14 meters per second. That's approximately. So if you've gotten it, y is 40 meters per second. If you've gotten this y, to get the time, they tell you find the time. The time you're always going to get is simply, since he started here, he wanted to move like this, but because he wants to get to the north, his boat will head west, north of west, in order to meet this. That's how he will head his boat, by his own will. That's what you'll be checking, by his own will. he will wheel his boat this way, wheeling, not what the river will do. If you will it by what the river will do, this is the diagram you will have, and it's going to affect your answer. It will affect the direction you will put there, because in the option you might see like this 37 that I've gotten now. In the option you might see n 37 degrees west, or you see n 37 degree east. If you use this, at the end of the day, you might even end up doing east 37 degrees north. You will see the option there as well, and you will fail it. So use his own will. His will, he will he will be willing to move towards the west, and at the end of the day, both will get him, like the current of the movement of the river will get him to the north. But in his own way, this is how his boat will head, and this is west. And notice the angle you will make, the angle made by that movement when he gets here is now his boat meeting the north, and the north you have here is the north you have here. But this time around, you will not judge the angle by alternates to say that this is the angle from where he started, since he made the angle at meeting point here. This is how you need to think. Do you need to think outside this? You face the consequences. So now see, at this point, to calculate the time, see that he has done everything and he gets here. He gets here. Now check. This is the full length of what he did. And this is the, or should I say, horizontal aspect of what he did inside this movement. Like this is like everything here is like this a diagram of his velocity and distance covered. So to find the time it took him, he's simply going to be gotten from S equals to UT. S equals to UT. Remember that he was not jumping inside that boat. He was not jumping for you to come and include plus half GT square, G gravity. No, he was moving. So, and I've told you that before. So in a case where you're now looking at the gravity, you use S instead of H, and you don't include G. So this is going to be, to find the time, you do T equals to S over U, which is equals to the S you will use. The S you will use is the S from here to here, and the U you will use is the velocity on this. So in fact, the S you will use is any S given to you in that question. There is the distance. So, and the distance given to us for that river, remember, is the river's distance. So the U given to us, the S given to us, sorry, is 50 wide, and this is on this side 40. Guys, the velocity will go here is 40. So I'm not telling you to limit to yourself. Any place they give you distance, whatever distance they give you, that's what you will use. When you're distance of the river, that's what you will use. And velocity covered, that was covered to get to the final point. So distance of the river over velocity covered, or final velocity covered, or you say vertical axis. So if you know this is going to be 50 over 40. 50 divided by 40 will be 1.25 seconds. This is how you go about it. Now, another case is when it has to do with airplane. So what it means is that if boat is moving, anytime it has to do with boat question, think in this way, because physics is a physical something. If it's a boat, think in this way. If it's a motorbike, think in this way. The way I've done it. If you hear somebody swimming, think in this way. If somebody is swimming, the person won't go much distance for. In fact, if you are swimming and current start to control you so much that you don't have your own will, it's drowning, you are going to drown. So think in this way. If it's swimming, think that the velocity given of the person's movement is this way. The river's current is this way. So at the end of the day, you are now looking for this one. So that thing you did, that place you found fault, what you are going to do is to use Pythagoras now to find this one. To find this one. Or if you are not given theta, in that case, if you are not given theta, you will now do using this now, theta will be equals to, if you look at this, is opposite over hypotenuse, and you are not given this. So in order to find this, in order to find theta, you first of all use these two to find the resultant. When you find the resultant, you will now find the theta. If that one is like, if you don't understand what I'm saying here, write it in the comment section, so I'll put the answer there. So, but for airplane, when you hear plane is moving, they tell you that plane has an airspeed. Whatever airspeed that plane has, is the speed of that plane. Now, if they tell you, let's say an aeroplane is moving at 150 bearing, you need to remember that bearing first of all starts from north, east, west. North, east, south. Are you okay? West. So the only thing is that, unlike circles that you normally start from east and going this way, here you are starting here 0, 90, and you do this 0. You put 0 in front of anything you are doing. That is, you put everything you are doing in 3 digits. So this is going to be 180. This is 270. And this is also 360 degrees. So if you hear 150 here, it means 90 plus 60 will give you 150. It's going to be somewhere here. And that means it's going to be 150 degrees. Or you say east. East is where the angle 60 will come from. 90 plus 60 is 1. So east is going to be the same thing as saying, it's also the same thing as saying east 60 degrees south. That is 60 degrees south of east. So if you've gotten this, if you hear that it's moving this way, and they tell you that a wind is blowing from 80 degrees or 080 degrees, this is from here to here is 90. So 80 degrees should be, let's say, somewhere here. If you find that 80 degrees, if you hear from means, if it means from here and you push it here, it's still going to where it's from. Wind moves from this axis to this axis. So if you hear from here, it means it's going this way, opposite direction. So that means angle here is also here. So this is that 80 degrees. And if you check it, if you now, this is going to be, it's either you call it S 80 degrees west, which is the same thing as saying 80 degrees west of south, or you put it this way. How I'm calling it, that's how it is called. So if you know this way, or this thing that you do here is the same thing as saying, if you start from the north to check it, you see that this is, everything here is 180. Is 180 plus that 80 is 260 degrees, or you say just 260 degrees. This is how to do bearing. You say just 260 degrees. So by the time you check this, you've gotten something like this, and you've gotten something like this. What you now need to look at is now it's like this. It's now this way and this way. And I've told you, anytime you have inside a quadrant, and you see vectors, these are vectors in different direction, all you need to do now, if this is 60 degrees and this is 80 degrees, that is vertically opposite angles. If you don't remember this one, you can just say, starting from the beginning, run it around, you get the angle. So by the time you do this, anytime you have this, you can actually say find this now, join it. You now use parallelogram method to solve. And using parallelogram method, you simply do, whenever you are finding resultant, is a bit different from cosine rule. You do r square equals to x square plus y square plus, if it's cosine rule now, you put minus, but you put plus because you are trying to, it's not just side you are finding. What you are trying to do is to bring it together to find the resultant, addition. So you do 2xy cos whatever angle you have. And in that case, if you are doing this, the angle you have, whatever angle you get by doing, check it out, you see that this is 60, this is 90 plus 80, it should be around, or 90 plus 80, 110 or so, plus 110. Sorry, what are you doing? 90 plus 80 become 170. Sorry. So you put it. So by the time you do this thing, by the time you solve this thing, you must have found the ground speed. That thing will be the ground speed. That thing will be the ground speed. But if you don't want to do this thing like this, because if you do like this, at the end of the day, to find each of the angles, you now start using sine rule. I don't want to solve this question, it's long. And I don't want this video to be long. But another way, in order not to stress yourself like this, remember what we did in class. Once you see vectors in this direction, just resolve it. Bring out the velocity one side, bring out the x-axis, bring out the y-axis. Now find the velocity here. Let's say they give you the velocity here to be 30 and the one here to be 100. Find for 30, find for 100, or resolve it using ESTC. When it is away from the angle, you use sine. When it's towards the angle, you use cos. So if this is, I didn't want this video to be this long, but if you are finding it hard to understand this, check out the next video I will make, the next video that will be made on relative velocity, and be in class. So thank you. Bless.